All right, everybody. Taking some cross products here. So remember, the cross product is just a fancy way to multiply vectors. And what's special about it is we can multiply two vectors together and get another vector out of it. This is the only operation um, like this that you will learn this quarter. So if I want to do this first one here, so let me, whoa, block myself off. So if I want to do A cross B, then what I need to do is I need to find the determinant of this matrix. So you put I hat, J hat, and K hat up top, and then we have 1, 2, 0. I'm a little slanted. 0, 0, 3. Okay, now here's how you do it. For the I direction, you're going to do 2 times 3 minus 0 times 0. So I will get 6 minus 0. Plus, now for the J direction. J direction's a little weird. We go the other way. So now I ignore my J column, and so I'm going to do 0 times 0 minus 1 times 3. So I will get 0 minus 3. And then I have a K direction. And the K direction is just like the X direction again. It's going to be 1 times 0 minus 2 times 0. So this is 0. So the vector we get out of it is 6, comma, negative 3, comma, 0. One interesting check you can do, the vector that comes out of this cross product will always be perpendicular to both of these vectors. So if you take a dot product of this thing with either of these vectors, you're going to get 0. Okay, so you can check that, and that'll be a good check if you did your cross product correctly. Okay, now let's see this next one. So we're going to need to do the determinant. So A cross B equals, so I have my I, J, K, 1, 1, 1, 0, 3, 2. So I'm going to get for my I hat, I'll have 1 times 2 minus 1 times 3. So that's going to be 2 minus 3 plus J hat. J hat's a little weird. So we go backwards. I get 1 times 0 minus 1 times 2. So that's going to be 0 minus 2. And then plus the K hat. We'll get 1 times 3 minus 1 times 0. So we will get 3. So A cross B equals negative 1, comma, negative 2, comma, 3. Okay. Now for this one, I might go a little faster. I personally stop writing these IJKs. You get used to it. 3, 5, 2. But I kind of always have to write them like this, otherwise I can't do it. So we will get, for my x, I will get 8 minus 15. So that's going to be negative 7, right? 8 minus 15, yep. Now for my y direction, I'm going to have 9 minus 2, so that'll be 7, comma. And then for my z direction, I'll have 5 minus 12, so that's negative 7 as well. 5 minus 12, yeah. Wow, negative 7, 7, 7. It's a lucky number how it came out. So once again, if you take a dot product of this thing, remember this is A cross B. It's a vector. This should be perpendicular to both of these vectors. So if you take a dot product, you should get 0. Basically what I mean here is A dotted with A cross B is always 0. Likewise for B. Okay. So that's how you do it. The cross product is just kind of a funny formula. And then the other thing that you see sometimes is that the magnitude of the cross product is equal to magnitude of A, magnitude of B, sine of theta. I think you've probably seen this before. This is a handy trick to evaluate the magnitude of a cross product. And we can use that to find the angle between the two vectors, similar to how we've done with the dot product in the past. But yeah, this is for the magnitude of the cross product. If you want to actually evaluate the cross product itself, these determinants are the way to go. And once you get used to the mechanics of how to actually do it, then the determinant is really easy to work with and works every time. This one down here I've seen get students in trouble, but it's fine if you're careful. But that is our problem.